Okay, this question was sent to me by a Year 12 Specialist Maths student. So we've got two curves. This curve 1 is the line y equals 4. In the domain x is 0 to 4. So we're from 0 to 4. This curve 2 is the line y equals 2 sec of x, again, from the line where x is from 0 to 4. So we're intercepting here at pi on 3, 4. So the region between the two curves, so that's this region here, is rotated about the x-axis. So we're going to have this region creating a kind of curve, like a tube, and we're looking for the volume, the exact volume of this region rotated about the x-axis. So our formula for this volume will be volume will equal pi times the integral from a to b of y squared dx. Okay. So that's our formula for each part of the volume. And what we're going to need to do, our total volume will be the volume of the first curve. So our total volume will be the volume of the first curve minus the volume of the second curve. So if we think about it from this direction, if I just look at the first curve, I'm going to get this nifty cylinder. I can find that volume. And I could do that geometrically. I'm going to use calculus for it, but if you feel like you want to do that geometrically, absolutely, you do it geometrically. That would be absolutely fine. But I'm going to do it with calculus. So that's my first volume, and then I take away this volume here, and I'll be left with the tube of those two volumes. So let's set up our equation. So our equation is, our volume is equal to pi times the volume, times the integral, from 0 to pi on 3 of 4 squared dx minus the integral from 0 to pi of 3 of 2 sec x squared dx. Okay, so this part here is the volume of this cylinder, and I'm taking away the volume of this cone. All right, let's tidy this up. So I've got, this is equal to pi times the integral from 0 to pi on 3 of 16 dx. And I'm subtracting. Now I'm going to have to square everything here. So I'm going to use my my integral knowledge to put this 4 out the front. So I'm going to have 4 pi. There should be a pi here. Sorry about that. So that should be a pi times the integral from 0 to pi on 3 of sec squared x dx. So let's have a look at what I've got so far. So I'm looking for that kind of tube coming through here. So I'm going to take the volume of the cylinder, and I'm going to take away this kind of trumpet shape. So the volume of the cylinder is my y-coordinate, and these discs along the x-axis are all summed together by the integral, and I take away this curve here. So I made the cylinder, and then I'm hollowing that cylinder out. Okay. I square everything here. 2 squared is 4. I can put that 4 out the front. And now I conduct my anti-differentiation. So my volume is equal to pi times, so I'm taking pi out as a factor completely, and I'm going to get the antiderivative of 16 is 16x, evaluated from 0 to pi on 3, minus 4 times the antiderivative of sec squared x, which is tan of x from 0 to pi on 3, and that's what I'm evaluating here. Okay, let's shrink all of this down so we can get this onto one page. If you ever want a copy of these solutions as I write them, as they end up, shoot me a message and I can send that through to you. So there's what I'm evaluating. So let's do this calculation. So volume is pi times. Now I'm going to have to go 16, and instead of x, that becomes pi on 3 minus 16 times 0. I'm taking away 4, being really disciplined with my brackets. Tan of pi on 3 minus tan of 0, close bracket, close bracket, close bracket. Okay, so I've got these big brackets, these internal brackets, and these function brackets. Now, a couple of things happen straight away. What happens when I multiply by 0? I cancel, so this disappears. And what is tan of 0? Tan of 0 is 0, so that disappears. So I can write this now as pi times 16 pi on 3 minus 4 times tan of pi on 3, close bracket, close bracket. I need to now find tan of pi on 3, so I mock up my exact value triangle. Some of you will be memorizing tables. I don't recommend that. I recommend learning where these values come from and using the triangles. Much more straightforward. So from this, I've got tan of pi on 3. Tan is opposite over adjacent, so this is root 3. So I get pi times 16 pi on 3 minus 4 root 3. I'm going to take 4 on 3 out as a factor, so I'm going to get 4 pi on 3, and that will give me 4 pi minus 3 root 3 cubic units. All right, so that is my answer of that solid revolution. Okay. You absolutely can stop here. Okay. Unless the question asks for a particular form, anything correct and fully simplified will do. I like to have this as a nice clean one line in case I have to do calculations with it later. I don't like expanding it because I'd have a pi squared and that confuses me. I'd also have this ugly fraction that can't be simplified. So I like having fraction out the front, nice clean one-dimensional expression in the middle. Okay, I hope that was useful. Good luck.